When dealing with a large number of golf cart chargers, understanding electrical code requirements related to load diversity is crucial for safe and efficient power distribution. While the information provided does not explicitly mention specific diversity factors, we can discuss general principles and relevant code sections that might apply. Load diversity refers to the concept that not all electrical loads will operate at their maximum rated capacity simultaneously. This allows for a reduction in the overall calculated load when sizing electrical services, feeders, and branch circuits. The National Electrical Code, or NEC, provides guidance on calculating loads and applying diversity factors. However, specific diversity factors for golf cart chargers are not explicitly defined. Therefore, a detailed load analysis is necessary. Firstly, consider the individual charger's full load amperage, or FLA. In this case, each charger has an FLA of 9 amps. Secondly, determine the total connected load by multiplying the FLA by the number of chargers, which is 140. This gives a total connected load of 1260 amps. Thirdly, research the NEC for applicable sections on load calculations for similar types of loads. Article 220 of the NEC provides general requirements for calculating branch circuit, feeder, and service loads. Within Article 220, specific sections address different types of loads, such as motors, lighting, and appliances. While there may not be a specific section for golf cart chargers, you can look for guidance on similar loads that operate intermittently or have duty cycles that allow for diversity. Fourthly, investigate if any local amendments or interpretations of the NEC exist in Pennsylvania that might address load diversity for electric vehicle charging or similar applications. Local jurisdictions may have specific rules or guidelines that need to be followed. Fifthly, consider the operating characteristics of the golf cart chargers. If the chargers are used intermittently and not all chargers operate simultaneously, it may be possible to apply a diversity factor based on the expected usage patterns. This would require a detailed analysis of the charging schedule and the typical number of carts being charged at any given time. Sixthly, conduct a load study to gather data on the actual demand of the golf cart chargers. This involves monitoring the current draw of the chargers over a period of time to determine the maximum demand and the average demand. The data collected from the load study can be used to justify the application of a diversity factor. Seventhly, consult with a qualified electrical engineer to perform a load calculation and determine the appropriate diversity factor for the golf cart chargers. The electrical engineer can consider the specific characteristics of the installation and the applicable code requirements to ensure that the electrical system is adequately sized and meets all safety standards. Eighthly, consider the type of overcurrent protection used for the branch circuits and feeders supplying the chargers. The NEC provides requirements for the size and type of overcurrent protection devices, such as circuit breakers and fuses, based on the ampacity of the conductors and the characteristics of the loads being served. Ninthly, ensure that the wiring methods and materials used for the installation comply with the NEC requirements. The NEC specifies the types of wiring methods that are permitted for different applications, as well as the requirements for conductor ampacity, insulation, and grounding. Tenthly, pay attention to the requirements for ground fault circuit interrupter, or GFCI, protection for the receptacle serving the golf cart chargers. The NEC requires GFCI protection for receptacles installed in certain locations, such as outdoor areas and damp locations, to protect against electric shock hazards. 11thly, address the requirements for surge protection for the electrical system supplying the golf cart chargers. Surge protection devices, or SPDs, can help protect sensitive electronic equipment from damage caused by voltage surges and transients. 12thly, review Article 625 of the NEC, which covers electric vehicle charging systems. While golf carts may not be specifically defined as electric vehicles, some of the general principles and requirements in Article 625 may be applicable. 13thly, consider the voltage drop in the branch circuits and feeders supplying the chargers. Excessive voltage drop can cause the chargers to operate inefficiently and may even damage the equipment. The NEC recommends limiting voltage drop to a certain percentage of the supply voltage. 14thly, document all load calculations, assumptions, and diversity factors used in the design of the electrical system. This documentation should be kept on file and made available to the electrical inspector during the inspection process. 15thly, obtain all necessary permits and inspections from the local electrical authority before installing or modifying the electrical system. The electrical inspector will review the plans and specifications to ensure that the installation complies with the NEC and all other applicable codes and regulations. 16thly, consider the future expansion of the golf cart charging system. If there is a possibility that additional chargers will be added in the future, the electrical system should be designed to accommodate the increased load. 17thly, evaluate the use of energy management systems to optimize the charging schedule and reduce the peak demand. Energy management systems can monitor the power consumption of the chargers and adjust the charging rates to minimize the impact on the electrical system. 18thly, explore the possibility of using renewable energy sources, such as solar power, to offset the energy consumption of the golf cart chargers. This can reduce the reliance on the grid and lower the overall energy costs. 19thly, consider the use of smart chargers that can communicate with the electrical grid and adjust the charging rates based on grid conditions. Smart chargers can help to stabilize the grid and prevent overloads during peak demand periods. 20thly, implement a regular maintenance program for the electrical system and the golf cart chargers. This includes inspecting the wiring, connections, and overcurrent protection devices to ensure that they are in good working order. 21stly, provide training to the personnel who will be operating and maintaining the golf cart charging system. This training should cover the safe operation of the equipment, as well as the proper procedures for troubleshooting and repairing any problems. 22ndly, be aware of any potential hazards associated with the golf cart charging system, such as electric shock, fire, and arc flash. Implement appropriate safety measures to mitigate these hazards. 23rdly, consult with the manufacturer of the golf cart chargers to obtain information on the recommended installation practices and the specific electrical requirements for the equipment. 24thly, ensure that the electrical system is properly grounded to provide a safe path for fault current to flow back to the source. Grounding is essential for protecting against electric shock hazards and preventing equipment damage. 25thly, consider the use of harmonic filters to reduce the levels of harmonic distortion in the electrical system. Harmonic distortion can be caused by nonlinear loads, such as electronic power supplies, and can lead to overheating and equipment failure. 26thly, evaluate the use of power factor correction capacitors to improve the power factor of the electrical system. A low power factor can increase the current draw and reduce the efficiency of the electrical system. 27thly, consider the use of demand control strategies to reduce the peak demand on the electrical system. Demand control strategies can involve shedding non-essential loads during peak periods or using energy storage systems to provide power during peak demand. 28thly, explore the possibility of participating in demand response programs offered by the local utility. Demand response programs provide incentives for customers to reduce their electricity consumption during peak demand periods. 29thly, consider the impact of the golf cart charging system on the overall energy efficiency of the facility. Implement measures to reduce energy waste and improve the energy performance of the building. 30thly, stay up to date on the latest developments in electrical codes and standards. The NEC is revised every 3 years, and it is important to be aware of any changes that may affect the design and installation of electrical systems. 31stly, consider the use of a qualified electrical testing laboratory to verify the safety and performance of the electrical system. Electrical testing laboratories can perform a variety of tests, such as insulation resistance tests, ground impedance tests, and overcurrent protection coordination studies. 32ndly, ensure that all electrical equipment used in the golf cart charging system is listed and labeled by a recognized testing laboratory such as Underwriters Laboratories or all. Listing and labeling indicate that the equipment has been tested and found to comply with applicable safety standards. Thirdly, consult with the local utility to determine the availability of electric service and any requirements for connecting the golf cart charging system to the grid. The utility may have specific requirements for metering, protection, and power quality. Fourthly, consider the impact of the golf cart charging system on the environment. Implement measures to reduce the environmental footprint of the system, such as using energy-efficient equipment and renewable energy sources. 35thly, develop a comprehensive safety plan for the golf cart charging system. This plan should include procedures for operating the equipment safely, responding to emergencies, and preventing accidents. By following these guidelines, you can ensure that the electrical system for the golf cart chargers is safe, efficient, and compliant with all applicable codes and regulations. Remember to always consult with qualified professionals for specific design and installation advice. It is important to note that without specific diversity factors provided by code or manufacturer specifications, the conservative approach to load calculation is generally recommended. This means initially calculating the load based on all chargers operating simultaneously and then working with a qualified electrical engineer to determine if a justifiable diversity factor can be applied based on usage patterns and other relevant factors. Consider NEC Section 220.17 regarding appliance load demand factors. If the chargers are considered appliances, then this section could provide some guidance. However, it's essential to determine if the chargers truly fit the definition of appliances as intended by the NEC. Also, carefully review NEC Section 625, specifically parts related to load calculations and wiring methods for electric vehicle supply equipment (OEFs). While golf carts are not cars, some principles might be applicable. In summary, the lack of explicit guidance in the information necessitates a thorough and professional engineering approach, involving careful load analysis, code review, and consultation with qualified experts. This will ensure a safe and compliant installation for the 140 golf cart chargers.